Okay, we are now doing the important rules. These are rules that are very important when you are doing differentiating using rules or differentiation using rules. I'm going to give you the first one. The first one says the derivative with respect to x of the sum or difference of two functions. Say you have got f of x plus g of x, and these two are being added. Now this is exactly the same as the derivative with respect to x of f of x separate, then plus or minus the derivative with respect to x of g of x. This is very, very important. That rule must be understood. So we are looking at an example just to make sure you understand what we are talking about. And it reads, if f of x is equal to x cubed plus 2x and g of x is equal to minus 2x squared minus 5, show that the derivative with respect to x of f of x plus g of x is the same as the individual derivatives of f of x and g of x. So this is what we are going to do. Our f of x is known. It is actually x cubed plus 2x, and our g of x is also known. It is actually minus 2x squared minus 5. So what are we doing here? We want to take the left hand side, which is the derivative of the sum of the two, which is equal to d dx of what is f of x? It's x cubed plus 2x. What is g of x? We are adding the two functions. It's actually plus minus 2x squared minus a 5. So we close the bracket. This will be equal to d dx of x cubed doesn't have a like term. X, we have minus 2x squared. I'm taking them in the power of in the order of the powers. Then plus 2x minus a 5. Now at this point we can differentiate. This will give us 3. Then we are now differentiating that. It will be minus 4x. We are differentiating that. It will be a 2. So differentiating 5 as a constant, we know is 0. Then we take the right hand side, which will be it's the derivative of the individual. So we have d dx of f of x, which is x cubed plus 2x, and then plus the derivative of g of x, which is minus 2x squared minus 5. We are now differentiating them separately, but in the left hand side we added them first. So what do I have? The derivative of this one is 3x squared. The derivative of this one is plus 2. The derivative of this one is minus 4x. The derivative of this one is 0. So this is the same as 3x squared minus 4x plus a 2. Aha, you see, left hand side is equal to right hand side. So with confidence we can say, therefore, d dx of f of x plus g of x is equal to d dx of f of x plus d dx of g of x, because we have confirmed it. Another rule that is important is for us to know that the derivative of a function In actual fact, it's another example. Yes, we are simply saying, we are now showing that d dx of f of x minus g of x is exactly the same as d dx of f of x minus d dx of g of x. We used a plus, now we are using a minus. So left hand side, it will be d dx of, we are subtracting the 2. Our f of x is 5x cubed minus 2 minus, in brackets, 2x squared plus x. We close. This will give us d dx of 5x squared minus 2 minus 2x squared minus x. Please take note of. Okay, this is 5x cubed. This is 5x cubed. I had actually erroneously said 5x squared. So no like terms, we can differentiate to get our answers. This will be equal to, that's 15x squared, because the 3 multiplies the 5. This is reduced by 1. Derivative of a constant, 0. For this one, the 2 multiplies the minus 2, that's minus 4x. And for this one, we get a minus 1. That is what we have on the left hand side. Right hand side will be the derivative of the individual. So it's d dx of, the first one is 5x cubed minus 2 minus d dx of 2x squared plus x. Now when you differentiate this, you get 15x squared, a constant, you get 0. Minus, and make use of your brackets as usual. The derivative of this, that's 4x. The derivative of this, that's 1. And make use of your brackets. Now you are removing brackets. This is 15x squared minus 4x minus 1. Therefore, left hand side is equal to right hand side. We can make a conclusion that this is also true. Therefore, d dx of f of x minus g of x is the same as d dx of f of x minus d dx of g of x. Let's move on to the next. We are now looking at number 3. Number 3 says d dx of a constant k multiplied by f of x is exactly the same as a constant multiplied by d dx of f of x. So there we are. We are now going to use an example. Our f of x is equal to x cubed plus 2x. So that's our f of x. So what we need now is to find the derivative of f of x with respect to x. Differentiate this, that's 3x squared. Differentiate that, that's plus 2. Now you need to understand that we introduced a k. So let me start here. I think this is not very accurate. I want you to understand what's happening. Our f of x has been multiplied by some k. So it will be k multiplied by that, that's kx cubed. Then for that, it will be plus 2kx. So we are finding d dx of k f of x. So we are differentiating now. This becomes 3k x squared. This becomes plus 2k. This is our left hand side. The right hand side is saying our k multiplies the dx of what? Of f of x. This will be k, the derivative of f of x, I did it there. It will be multiplied by 3x squared plus 2, which will then give us 3k x squared plus 2k. The left hand side is equal to the right hand side. Therefore, this is true. Therefore, d dx of k f of x is the same as k d dx of f of x. Very, very important for us to understand, good people. Now, number 4, okay, we have to do an example for this one. If f of x is equal to x cubed plus 2x, it's the same as above, I can see that. So we want to show that this is very true. That's what we have done, isn't it? Yes, so I can't repeat that. Let me go on to number 4. Now we are saying, please notice that d dx of f of x divided by g of x is never equal to d dx of f of x divided by d dx of g of x. This is never true. And accompanying to that is d dx of f of x multiplied by g x is never equal to d dx of f of x multiplied by d dx of g of x. Boys and girls, I want you to try this with any function of your choice, but I'm going to quickly do this one for only the multiplication. It is saying left hand side is equal to, we are finding d dx of the product of f of x, which is 2x minus x cubed, multiplied by g of x, which is 2x squared minus 3x. So all we are doing here is to expand before we do the derivation. This times this will give us 4x cubed. This times this will give us minus 6x squared. This times this will give us minus 2x to the power 5. This times this will give us plus 3x to the power 4. It is already in the differentiable form, so we can apply the rules, and then we don't write this anymore because we are differentiating. That's 12x squared, because the 3 multiplies the 4 and 3 reduces by 1. That's minus 12x. That's minus 10x to the power 4. That's plus 12x cubed. Then we take the right hand side. Right hand side, what are we doing? We are differentiating them separately. So d dx of f of x, what is f of x? We know our f of x is 2x minus x cubed plus, no, we are multiplying. Please don't make that mistake. D dx of what is our g of x? 2x squared minus 3x. So we are busy now differentiating. This will be, differentiate this, that's a 2. Differentiate this, that's minus 3x squared. And this whole thing is multiplying, make use of brackets. That is 4x minus 3. Let us expand. This times this, 8x. This times this, minus 6. This times this, minus 12x cubed. This times this, minus, it's a plus, 9x squared. Do you notice that the left hand side is not equal to the right hand side? Therefore, this is never true. Thank you. Your work. Exercise classwork, exercise 7, number 2 only. Homework, exercise 7, numbers 3 and 4. Thank you very much. Enjoy your work.